Good afternoon, students. Now we have reached chapter 5. It's about the IT infrastructure and emerging technologies. So, for the study cases, we will check a case about Southeast Asia's Grab leverage information technology to enhance its services. So, after you learn this chapter 5, it is hoped that you will be knowing about what is IT infrastructure and what the stages of the IT infrastructure and the drivers of the evolution, and also the components of the IT infrastructure and the current trend of the computer hardware and software in this trend. So let's begin with the study cases. So as usual, I put the YouTube link in this slide. So hopefully you check the YouTube first before you go on to the next slides. Since I cannot play the YouTube, so you need to play by yourself, okay? So it's about Grab. The Southeast Asia's Grab leverage information technology to enhance its services. So this is the studies case article you can read later. But for now, we'll briefly explain what is it about. Okay, so the Grab, it's a Singaporean-based company which offers taxi booking, food delivery, and mobile payment service through its smartphone app. It's founded in Malaysia in 2012. The Grab rapidly expanded across the Southeast Asia and now operates in several countries. With 6,000 employees and 2.8 million registered drivers, the Grab app is downloaded on 185 million devices and books over 6 million rides daily, which generate around 2.3 billion in revenue in 2019. Leveraging information technology, the Grab ensures a reliability of taxi service by provide the transparency through the driver ratings and major fares via its app. It utilized the Amazon Redshift and Elasticgate services for the data management and real-time tracking. This will optimizing the driver allocation using data analytics. And through the partnerships and initiatives like the e-payment platform and the Grab platform, it aims for broader adoption of digital services in the Southeast Asia. With 1.4 billion funding in 2019, Grab continues to expand its integrated services. So the study case was about Grab's effective use of information systems highlights how the technology can enhance the organizational performance by optimizing the resource management and meeting customer demand efficiency. By leveraging real-time monitoring and data analytics, Grab ensures timely positioning of drivers to maximize the capacity and of course to minimize the customer wait times. This strategic approach is crucial for competing in the markets with efficient public transportation system like the Singapore. Utilizing cloud-based service from the Amazon, it enables Grab to focus on the app's enhancement while benefiting from the robust infrastructure support. This raises questions about the role of hardware and software in Grab's expansion across the Southeast Asia and the significance of the cloud computing in its operations. Now let's see what is the infrastructure of IT, which includes the stages and the drivers of its evolution. An IT infrastructure consists of a set of physical devices and software applications that are required to operate the entire enterprise. But IT infrastructure also includes a set of firm-wide services budgeted by the management and composed of both human and technical capabilities. These services include computing platforms, telecommunications, data management, application software, physical facilities management, IT management, standards, education, and research and development. Viewing IT infrastructure from a service platform perspective highlights its business value. For example, while the hardware and connectivity of a personal computer may seem straightforward, understanding how it enables a high cost employee to access the critical systems and the internet reveals its true value in enhancing the productivity and efficiency, which ultimately impacting the firm's overall performance and profitability. Now let's move to the evolution of IT infrastructure. So, the evolution of IT infrastructure has progressed through five distinct eras. The general purpose mainframe and the mini computer era is start from the 1959, sorry. So the widespread commercial use of mainframe computers, which provide the centralized computing controlled by the professional programmers. The introduction of mini computers by DEC, decentralized computing, allowing customization to specific business units. And then the personal computer era from 1981 saw the widespread adoption of PC, personal computer, in businesses, leading to the development of personal desktop productivity tools. Next, the client and server era. It started from 1983, introduced the desktop or laptop clients network to powerful servers, enabling the distributed computing. Next, the enterprise computing era. From 1992, it focused on the integrating disparate networks and applications into an enterprise-wide infrastructure using TCP or IP. And finally, the cloud and the mobile computing era. It starts from the year of 2000. So the emergence of cloud computing, which provide the access to shared computing resources over the internet, leading to significant growth in the public cloud spending. These eras have each contributed to shaping the modern IT landscape, which facilitate the efficient operation of businesses and enabling technological advancement. For your better understanding, you can check this figure for each of the five stages evolution. Each represent a different configuration of computing power and infrastructure elements. So this is the enterprise computing and the cloud mobile computing. Meanwhile, simple client or server networks can be found in small businesses. Most corporations have more complex, multi-tiered a client or server architectures, which often called entire client or server architecture, in which the work of the entire work is balanced over the several different levels of servers depending on the kind of service being requested, as you can see in this figure. Now let's move to the technology drivers of infrastructure evolution. So, the evolution of IT infrastructure has been driven by advancement in the various technological components, includes the computer processing, the memory chips, and then the storage devices. Networking hardware and software and the software design itself also one of the advancements in the technological components. The Gordon-Morrow's observation, known as Morrow's law, stated that the number of components on a chip doubles approximately every 2 years, which leads to a exponential growth in the computing power and a corresponding decline in cost of the IT, as shown in the figure of 5.4. So, to address this, nanotechnology is being explored to create even smaller components, which potentially revolutioning computing with the technology called nanotube processors. So, these technological drivers have shaped the trajectory of IT infrastructure evolution and continually enhancing the computing capabilities while driving down the cost. So, the nanotubes are the tiny tubes about 10,000 times thinner than a human hair, and they consist of rolled up sheet of the carbon hexagons, as you can see in this picture, and it has a potential are used as mean use cool wires or in the ultra small electronic devices and is very powerful conductors of electrical current. Additionally, the law of mass digital storage observes that digital information doubles annually while storage costs decline exponentially. So this figure 5.6, shows that the number of megabytes that can be stored on the magnetic media for $1 from 1950 to the present roughly doubles every 15 months. So in 2020, 1 terabyte of hard disk drive sells at the retail for about $50. So Metcalfe law, which proposed by the Robert Metcalfe in 1970, asserts that the value of a network grows exponentially with the number of its users. This concept highlights the increasing returns to scale experienced by the network members as the network expands. As more individuals join the network, its overall value increases exponentially, leading to the continuous growth in the value with each member. This principle explains the demand for computing and the storage power, as it underscores the social and the businesses benefits derived from the digital networks. By rapidly expanding the number of connections among the network members, the digital networks enhance their social and the business value, driving the demand for information technology resources. Furthermore, the declining communication cost and the expansion of the internet have significantly transformed IT infrastructure, facilitating widespread connectivity and the utilization of commuting facilities. Let's check the figure 5.7. So this figure illustrates the exponentially declining cost of communication both over the internet and over the telephone networks, which increasingly are based on the internet. As communication costs fall towards a very small number and approach zero, utilization of communication and computing facilities explode. So in 2008, the consumers paid about $9.01 per megabytes for the internet access. And after 10 years later, in 2018, the price had shrunk to 0.76 per $0.76 per megabytes. So the agreements among the manufacturers and the widespread acceptance of the technology standards are now crucial for today's enterprise infrastructure and the internet computing. The technology standards are rules that ensure the products can work together and communicate effectively in a network. These standards lead to economies of scale, driving down the prices as manufacturers focus on the producing products that adhere to a single standard. Without such standards, computing would be much more expensive. So in 1990s, businesses began adopting standards platform like the Wintel PC with Windows and Microsoft Office, along with the Unix Linux for servers. Standards like the Ethernet for local networks and the TCP or IP for wider networks, including the Internet, have been pivotal in the shaping modern IT infrastructure. So now let's check what are the components of IT infrastructure. So IT infrastructure today is composed of seven major components. The figure 5.8 illustrates these infrastructure components and the major vendors within each component category. These components constitute an investment that must be coordinated with one another to provide the firm with a coherent infrastructure. And later on, we are going to discuss about this one by one. So IT infrastructure have seven main components, and the first one will be a computer hardware platform. So in 2020, the global expenditure on computer hardware devices, ranging from the mainframes to smartphones, is projected to reach more than $600 billion, serving both corporate and personal computing needs. The dominance of Intel and the AMD processors has shaped the business computing with their chips powering most systems. The advent of mobile devices like smartphones has introduced a second hardware platform which catering to consumer driven demands. And the mobile processors designed by the various firms including the Apple or Samsung, it operates with less power consumption. Despite the technological advancement, the mainframes remain crucial for handling large-scale transactions and data analysis, with IBM being the primary provider. Repurposing the mainframe systems into massive servers underscores their enduring significance in modern computing infrastructure. The second one is operating system platforms. So, operating system platforms play a crucial role in the manage the resources and the activities on both corporate servers and the personal computers. And the Microsoft Windows servers like Unix and also the Linux are among the leading operating system for the corporate servers. They are offered the scalability, reliability, and compatibility with various processors. Meanwhile, over 80% of PCs use some form of Microsoft Windows, although there's a growing variety of client operating systems for mobile and the cloud connected devices. For instance, like Google Chrome OS is designed for lightweight cloud computing, while Android and iOS dominate the mobile operating system market. In the realm of the enterprise software application, firms invest significantly in software solutions like SAP and Oracle for the various business functions, with a middleware facilitating integration across the existing system. The next one is data management and storage. The enterprise database management software is responsible for organizing and managing the firm's data so that they can be efficiently accessed and used. The leading database software providers are IBM and then Oracle, Microsoft like SQL servers, and then SAP Sybase. Uh, it's an adaptive server enterprise. And MySQL is a Linux open source relational database product which is now owned by the Oracle Corporation. And Apache Hadoop is an open source software framework for managing very large datasets. Next is the networking or telecommunication platform. So, telecommunication services, including the voice and data connectivity, the wide area networking, and the wireless services, are typically offered by the companies like AT&T and Verizon. This sector is witnessing the rapid growth with new providers emerging to offer cellular wireless, high-speed internet, and the internet telephone services. So in 2020, companies worldwide are projected to invest heavily around $1.5 trillion in the telecommunication services as reported by the Gartner Incorporation. Windows Server is the primary choice for the local area network operating systems, with Linux and Unix following suit. The enterprise-wide area networks mostly rely on Unix variants, and the TCP or IP protocol suite is widely adopted for both local and the wide area networks. Leading providers like Cisco and Juniper Networks dominate the networking hardware sector. Next is the Internet platform. So, Internet platform encompass the hardware, software, and management services essential for supporting a company's website, comprising the web hosting services, routers, and networking equipment. The web hosting services offer space on servers for maintaining the websites, and the surge in the internet usage has led to a proliferation of server computers, prompting efforts to consolidate by enhancing servers' capabilities and utilizing software for running multiple applications on a single server. Standalone server usage is diminishing as businesses transition to cloud computing. So the IBM, Dell, Oracle, and HP dominate the internet hardware server market due to significant price reductions. The major web software development tools are provided by Microsoft, Oracle Sun, independent developers like Adobe. The last one, the last main component for the IT infrastructure is consulting and system integration services. Large firms often lack of resources and expertise to deploy and manage their entire IT infrastructure. So, implementing the new infrastructure involves significant changes in processes, training, and software integration. Leading consulting firms like Accenture, IBM Services, HP, Infosys, and Wipro provide the expertise in this area. So, the software integration is crucial for ensuring the compatibility between new and legacy systems, which are older transaction processing systems used to avoid the expense of replacement. Integrating these systems into modern infrastructure is preferred due to the high cost of replacement and the redesign. The exploding power of computer hardware and networking technology has dramatically changed how businesses organize their computing power, putting more of this power on networks and, of course, the mobile handheld devices and obtaining more of their computing capabilities in the form of services. So, in this section, we take a closer look at 8 hardware trends. The first one is mobile digital platform, consumerization of IT and BYOD, and then quantum computing, virtualization, cloud computing, edge computing, green computing, and high performance power saving processors. Let's talk about them one by one. So, the first one is the mobile digital platforms. The first platform will be the mobile digital platform. The rise of mobile digital computing platforms, such as smartphones and tablets like the iPad and Android devices, has transformed the way people access the internet and conduct businesses. So these devices, along with the netbooks, tablets, and the ebook readers, offer functionalities similar to the PCs, personal computers. For instance, British Airways service agents used iPads and custom apps for the customer engagement, flight updates, and luggage tracking. The wearable uh, computing devices like smartwatches and glasses have also emerged. This offering the convenient access to information for workers in various industries such as warehouses and field operations without disrupting their task. The next one is about BYOD. BYOD is bring your own device. Okay. So the rise of smartphones and tablet computers has led to the BYOD, bring your own device, where the employees use their personal mobile devices for work purposes. This trend is part of the consumerization of IT, where the consumer technologies enter the business organizations. Along with the personal devices, the businesses are adopting consumer oriented software services like Google and then Dropbox and social media platforms. And this shift challenged traditional IT practices where the IT department controlled the technology selection and the management. Now, the employees and the department have more influence, demanding access to the corporate networks with their own devices. This poses challenges for managing and securing consumer technologies to meet the business needs. Now, quantum computing and virtualization. So, quantum computing harnesses quantum physics principles to process the data in states of 0, 1, or both simultaneously. This offers the unprecedented processing power for solving complex problems. So the IBM, the Google's Alphabet, Microsoft, Intel, and NASA are leading this field. Virtualization, on the other hand, abstract the computing resources like servers or storage, It allows them to be accessed without physical constraints. The VMware is a key player in server virtualization, which significantly boosts resource utilization rates, reduce the cost, and improving the efficiency. And additionally, software defined storage or SDS pools and manage storage resources, which also enables the flexible allocation and cost saving by the utilizing the commodity hardware and cloud storage. Now, cloud computing. Cloud computing revolutionized the way computing resources are accessed and utilized by providing a shared pool of virtualized resources over the internet. This model, as defined by NIST, offers essential features such as on demand self service, ubiquitous network access, and rapid elasticity. It also compromises the infrastructure as a service, and then software as a service, and the platform as a service, which allow the users to leverage the computing resources, software applications, and development tools remotely. The public clouds, like those offered by Amazon Web Services, cater to broad usage scenarios, while private clouds manage internally or externally over tailored solution for the specific organizations. Despite concerns about data security and availability, this trend is towards increased adoption, particularly beneficial for the startups and small businesses. Larger firms often employ a hybrid cloud approach, combining the private infrastructure with the public cloud services for enhanced flexibility. This shift towards the cloud computing signifies a move from fixed infrastructure to a more dynamic and scalable computing environment. Edge computing. So edge computing optimizes cloud system by distributing processing tasks to servers at the network's edge, which also reduce the data transfer volumes between the local devices and the central clouds. It's especially useful where the constant cloud connection is not needed, like on the remote oil rigs with the sensor data. By transmitting only vital data, it lessened network traffic and minimized delays in data processing. It's a critical for time-sensitive application such as finance, manufacturing, and autonomous vehicle. Green computing, also known as green IT, focuses on the reducing the environmental impact of computers and associated devices. The virtualization plays a significant role in this endeavor by curbing the hardware proliferation and the power consumption. The data centers, which consume a substantial amount of energy, are being designed with the energy efficiency in mind, incorporating state of the art cooling techniques, energy efficient equipment, and virtualization. The tech giants like Microsoft, Google, Facebook, and Apple are leading the charge by investing in the clean energy powered data centers. Additionally, the use of high performance and power saving processors featuring multiple cores of processors on the single chip further reduces the power requirements and the hardware sprawl. These advancements not only improve the energy efficiency but also enhance the performance, making them crucial for a variety of devices, including the smartphone, tablets, cars, and healthcare devices. So, it was the current computer hardware platform. Now we will look into the current computer software platform and trends. First, we have the one who's called Linux and open source software. The open source software, which developed by the global community of programmers, is free and can be modified by users. Notably, the Linux and an open source operating system is widely used in the various devices like smartphones and consumer electronics. The other popular open source tools include the Apex HTTP servers, Mozilla Firefox, and Apex OpenOffice. The Google's Android and Chrome are also based on open source software. While Linux is not as prevalent on desktop system, it dominates the servers, mainframes, and supercomputers due to its cost effectiveness, reliability, and compatibility with major hardware platforms, which attract support from the corporations like IBM, HP, and Dell. Now let's check the software for the website. There are Java, HTML, JavaScript, and Ruby and Python. I'm sure that you have heard all of this. Okay, so now let's see one by one. The first one is Java. Java, an operating system independent and object oriented programming language, has become a staple for web development and expanded into mobile devices and consumer electronics. Its platform allows the software to run on various devices with a Java virtual machine, which enables the code to be written once and deployed universally. The Java applets can also be embedded in the web pages, enhancing user interaction. Meanwhile, the HTML, particularly HTML5, facilitates the dynamic web content integration, which includes the multimedia elements like images, audio, and video without additional processing. The JavaScript further enhances interactivity on the web pages with all major browsers supporting it. The next one, the Python and Ruby on Rails are popular programming tools for the web applications known for their flexibility and feature-rich capabilities. So now let's check the web services. So web services enables the exchange of information between different systems using universal web communication standards and languages, regardless of the operating systems or programming languages. The XML servers as the foundation technology for the web services provide the standards format for the data exchange and facilitates the automatic interpretation and manipulation of data by the computers. Through the XML message over the standards web protocols, the web services communicate and can be discovered and located through the directories. A service oriented architecture, or short by SOA, consists of self contained services that communicate to form a functional software application which enable the business's tasks to be executed through a series of interconnected services. The major software vendors offer tools and platforms for building and integrating software applications using the web services, with the Microsoft incorporating web services tools into its net platform. The dollar rent a car utilized the web services to seamlessly integrate its online booking system with the Southwest Airlines website, which leveraged the Microsoft.NET technology as an intermediary to translate reservation into web service protocols. And this approach streamlines the communication between the different systems without the need for custom links, facilitating direct connections with the other partners' information system and the wireless website for cell phones and of course for the smartphones. Here in figure 5.11, we can see that dollar rent a car employs the web services as a standardized intermediary software layer to facilitate communication with other companies' information systems. By utilizing this suite of web services, the company can establish connections with various companies' information system without the need to construct individual links for its firm system. This is a great one for a company, of course. So the business firms often rely on the external sources for software procurement due to the cost and complexity of replacing existing legacy systems. These sources include software package from commercial vendors, outsourcing custom application development, and cloud-based software services like SaaS and PaaS. The software package streamline functions like payroll processing and order handling, with the enterprise software vendors like SAP and Oracle, which offer the comprehensive solutions for the global business process. Meanwhile, for outsourcing software allows firms to contract custom software development to external vendors, often offshore. It reduces the cost and the leveraging the specialized expertise. The cloud-based services offer flexible access to software over the internet, which reduce the need for individual installation. The firms manage their relationship with the outsourcers through the Service Level Agreements or SLAS, defining the service expectations. Additionally, Mashup and apps are integral parts of the modern software usage, offering the flexibility and customization for personal and business tasks. The mashups combine various online applications to create the enhanced functionalities, while the apps, particularly those for mobile platforms like iOS and Android, have revolutionized the way we use the smartphones and tablets. The apps are increasingly utilized as the gateways to enterprise systems, reshaping the traditional website design. Their affordability and value selection contribute to the success of the mobile platform, with the apps tying the users to specific hardware platforms. From the entertainment to business utilities, the apps cater to diverse needs with a wide array of options available for both personal and professional use. Now we come up all the chapters with summary. So the evolution of IT infrastructure encompasses five stages. The first one is the mainframe era, the personal computer era, the client server era, enterprising computing era, and the last one is cloud and mobile computing era. This evolution is driven by the Moore's law, the law of mass digital storage, and Metcalfe's law, alongside decreasing cost of communication and increasing standardization. The major components of IT infrastructure includes the hardware, operating systems, and then the enterprise software, networking, data management, internet platforms, and consulting services. The current trends include the rise of mobile computing, quantum computing, consumerization of IT, virtualization, cloud computing, edge computing, and grid computing. Open source software, it includes the Linux, Java, JavaScript, HTML, and HTML5, web services are prominent software platforms. The businesses increasingly acquire software externally through the software package, outsourcing, and renting online services. So the mesh apps and the apps represent innovative approaches to software integration and delivery, particularly for the mobile devices. Okay, that's all of the chapter 5. If you have any questions, just send me email and I will see you in the next chapter. Goodbye.